attention and not look at Facebook or Twitter accounts or whatever that was. Okay? Start fresh. Everybody starts clean today, right? Everybody has 100 basically, right? Keep that 100. If everything gets turned in, you make everything well, you keep that 100. Oh, we're recording. He does not say. Yes, sometimes maybe I say the same wrong things, okay? Thanks, Nicolina. Appreciate you too. Okay, so first off, let's go over our rules of exponents, okay? Because that's important, just a little remembrance. Okay, does anybody remember if I had x squared times by x cubed? What is that going to be? Fifth. Because, notice, this is x, 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 x. Sorry. Yes, I did. Anyway, this is x to the fifth because there's 5 x's being times together, right? So once again, when they are like bases, what do we do to their exponents? We add them, right? So notice I went 2 plus 3 is 5. So once again, if I had a to the b times a to the c, what do I have actually? A raised to the what power? B plus c. That's our general form, right? Is everybody okay with that? Do you remember that? So notice if I had 2 squared times 2 to the fifth, what is that equivalent to? 2 to the 7. Nope. Still things. How many 2's do I have? Because I'm not timing the bases. I'm saying, okay, well, that's 2 times 2 times 2 times 2 times 2 times 2 times 2. Right? So how many 2's are there? 7 of them, so 2 2's. Right? You okay there? Everybody remember that rule? Okay. What about, if I have this rule? X to the 6th over x to the 4th. What do we do when we divide? We times, we add it. When we divide, we subtract, and that should make sense because that's x, 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 over x, 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 x. Right? Now, could you do this every time if you wanted? Draw out all those x's and go, right? And then you'd have x squared, right? What if I said x to the 100th over x to the 98th? Are you going to do 100 x's or 98 x's? Would that be fun? So if we learn the rule, it helps us in time, right? So this would be x squared because I go 100 minus 90. Right? So if I had a to the b over a to the c, what is our generic rule? It is a over b minus c. Now, with that being said, I want to know what would it be if I did this? If I said, okay, what if I had x to the 98 over x to the 100? What's he going to be? Not be imaginary. He's still there. So we could write it as x to the negative 2. Well, we don't like negative powers. Okay? Now, understand this. If I did the 98 up top and 100 down below, where is my x is going to be? On top or on bottom? Who do I have more of? On bottom. How many more do I have on bottom? What's going to be on top then? There's always something. There's always one, right? So that's 1 over x squared. Understand, if any time you have a negative exponent, okay, I have a little saying. Notice, I jumped the line and I changed my sign. Does that make sense what I mean by that? See how he was upstairs? He jumped downstairs and he changed his sign. Jumped the line, changed his sign. Okay? What if I was like this? Let's just imagine if I had x cubed over x to the negative 2. Well, times x squared, which is x to the fifth. Could I still get x to the fifth by doing subtraction? Because wouldn't I go 3 minus a minus 2? Well, what's 3 minus a minus 2? 3 plus 2, and that becomes the 5. Does that make sense? Everybody remember the division powers, the subtraction? Anybody else switching out? All right. Everybody understand when we have negative exponents what we're going to do? Jump the line, change the sign. If we're downstairs, we'll go upstairs. If we're upstairs, we'll go downstairs. Is everybody okay with that? Okay, yes ma'am. Yes, when we have negative powers. Now, what if I had negative 2 squared? Is that because these negatives I jump downstairs? No, the exponent does. Okay. All right. Now, what if I asked you what is 2 to the 0 power? Anybody know? It's not 0. It's not 0. It's 1. Oh. You want me to show you why it's 1? Let me show you. Well, let me explain why. Here's, I think, the reason behind it. Can anybody tell me what 2 squared is? Let's actually just go 2 cubed. What does 2 cubed mean? It is 8 because it's 2 times 2 times 2, right? 2 times 2 is 4 times that 2 again is 8. Everybody got that one? Okay. What is 2 squared? 4. How about 2 to the first? What's the pattern happening here? Are we minusing 2? We're dividing by 2, right? So therefore, if I go 2 to the 0, 2 divided by 2 is 1. Notice if I did 2 to the negative 1, this is also the reason why it works. What's 1 divided by 2? 1 half. Notice that's 1 equals. Jump the line, change the sign. What's 2 to the negative 2? Well, what's 1 half times a half? 1/4, which is the same thing as 1 over 2 squared, which is 1/4. You see how that pattern works as well? Does that make sense? Did you decide to get your new seating arrangement? Yes. No. Why? Well, nobody's going to sit in that row or that row. We're going to go by the person. The 3, you might be right there. You might be right there. Anyway, are we doing okay? Everybody understanding, remembering these rules? Okay, we have one more rule that you got to remember before we really get to our lesson today. What if I had 2 squared to the third? What would that be? It is 64. Okay. I just think that I love it. I just love this from everybody. I think it's 2 root 5. I think it's great. Okay. Notice. Let's just think about this. What does this mean? It means 2 squared times 2 squared times 2 squared, right? 2 to the 6th power, huh? Because notice when we have like bases, what do we do to their exponents? We add them, don't we? So, can anybody see how we got from 6 from here? We multiply. So when it's a power to a power, so for example, if I had a, b raised to the c power, what is that going to be in my numeric form? A raised to the what power? B times c. Does that make sense? Yes, no? By the way, that shirt's already a belly shirt for me after one wash, basically.
Mine didn't even strip at all.
Yeah. Your mom does. Yes, no problem. So once again, 2 squared, okay? And I understand, Tragan said this is 64, and that is 64, because 2 times 2 is 4, times 2 again is 8, times 2 is 16, 32, 64. It is 64, right? idea when we have a power to a power. What do we do to the exponent? We go, okay, what's x times 5? Or just multiply.
Okay.
Just multiply.
So what happens if that was like a 2? So it was like 3.
Square to the fifth. So like this.
Yeah, what I just.
Or what to the fifth.
Oh, okay. Well, let's do that.
Okay? Everybody good? Okay. Alright, so now we are going to start getting into what we're getting into today. We all excited? Yes, I am.
Wait, go back to the video. What are you doing? Why is it squared? Go over again.
She just asked what is that with square.
Oh, okay, okay. Got you.
All of a sudden that's just 2. She just asked what is it with so that's why we did that. Anybody? Where the heck did I lose my stuff already? Do I lose stuff like no other, huh? Do you think this? I like this shirt. My wife got it for me. I did have to take it back because of I've been wearing 2X's, but the 2X right there made me go like this and it turns different at the top and it go like that and I'm like, too young. So I decided to take it back because it's 100% cotton. I think it's pretty. Mr. Atkinson said since he was a male cheerleader, he can't wear pink. Just too blistered. I have pink!
I didn't have to split myself up.
I got a yellow, a pink, a light blue, and a dark blue. This is up here. Thanks for talking about my clothes. Thanks. All right, here we go. We're going to go all out. Here we are. Ooh, I like it. I like it a lot. Can I get you another seat, please? That's always great. You sure? It is pink. Yours was in this program. I thought it was all put in and out. Okay. Anybody have an idea what we're going to do? Just multiply, right? So we take the 4, we take the -3, and what are we going to do to it? We're going to multiply. So that's -12. 4 times -3 is -12. Just there. Well, we're still going with it. This is timesing. This is not adding. Could I add these two together? Because they're not like terms, correct? But I can always times things together, right? I just cannot add things together, right? Okay, what is my x's? What is my x's going to be? 8. How'd you get 8, Ian? Because remember, when you multiply like bases, you add the exponents, right? How about our y? There's our answer. That's good, huh? Hey, I can turn a 2 into most any number. Give me a number. 4. So here's a 2. I can make that a 4 easily.
I didn't want to know that.
A 7. That's simple. Basically. A 1. Oh, I can't do that. A 3. Oh, that's simple.
Come on, that's this one. You can do it.
0. Oh, that's good. Wait, okay. It's still 0. No, I think it's back there. Okay. What else? good time, right, guys? Got to learn and have a good time. Yes, I was all right with that. Ooh, I'm ready for this one. You guys ready? Well, I Do we have a question? Yes. That's what we can figure out, right? Okay, so first off, what I like to do is I get rid of my negative exponents. Okay? So, who belongs? Does that negative 3 still belong on top? Yes, because he's a number, not an exponent, right? Kids get that confused all the time. A number can stay there, right? An exponent has to jump. Everybody understand that? Or those guys are going to stay. Okay, what about that x to the second? Where's he going to go? He's going to jump down because he's negative, so therefore he jumped the line, changed the sign. How about that y cubed? Where is he going to stay? Is he moving or staying? He's staying, right? He's going to go on top. Go ahead, sir. Well, he's right here. So he's negative, so remember when he's a negative exponent, he jumps down and changes the sign. Jump the line, change the sign. I haven't got it quite done yet. No, I'm just moving. Where does he get to go? He jumps up. I haven't simplified yet. That's basically what I'm saying. And then x to the 4th, he stays down. Okay? So that's simplified, right? Is that simplified? No, because now I got y's on top and x on bottom. What does 3 and 12 have in common? A 3. So this is a 4. What's this number up here understood to be? A 1. So I'll just have a negative there. Y cubed times y. We'll have a negative y to the 4th, right? Everybody okay there? Okay? And then notice we have how many x's on bottom? X to the 6. Oh, then there's a 4 there. Negative, negative 1. Same thing, right? Okay, so let's see if we could have did that another way without having to go to this step. Could you do this step if you needed to? Yeah, but can we miss that step a little bit? We can. Okay, first off, negative 3 and 12, cancel that out. There's my 4, hit the 4's down there. Right? Make sense? Okay, what's negative 2 minus 4? Negative 6. And anytime I have a negative exponent, what do I need to do? Jump the line, change the sign. So notice, anytime you subtract, that will always put you on top. Does that make sense? So, negative 2 minus 4 is negative 6. But because he's a negative exponent, where should he be? Down below. X to the 6. Does that make sense? Kirsten, you're looking at me dirty. Well, no, so if I just start top, negative 2 minus 4, that's x to the negative 6. But negative 6, I got to jump the line, change the sign anyway, right? You okay there? What about 3 minus a minus 1? What's 3 minus a minus 1? 3 plus 1, which is... Does that make sense? Okay, let's go on. Let's see what you guys would do here. Ooh, dun, dun, dun! Every time I see her, I shoot that. Not about you, but some things just happen. She said, "Thank you for helping Brady pass the class." And I said, "He could have got a better grade if he just nailed in this quarter, turns everything in time, so that instead of getting 5, she gets 10. Right? and then that'll be a better grade. And that's what I said. So I can help. Okay, what I like to do first is order of operations. Order of operations says to do what? Parentheses. Work with inside the parentheses, right? Then go ahead. You could. Sure. How about I do it both ways? Okay. All right. So first off, I'm going to work on the inside. So does 4 and 5 do anything? They can't do anything, so there's still 4 and 5. How about x squared and x to the negative 3? How many x's and where is it going to be? James, go. 5 on the top, right? Why? Because x cubed's down, he's going to come up. So x squared's already up top, plus we're adding 3 more, so there's x to the 5th. Everybody understand where x to the 5th is coming from? It's already down, jumping up. We already have 2, so 2 plus 3 is 5. Any questions there? Now what? How many y's and where? 4? Where do we get 4 from? Y squared on top. Because notice this should make sense. Reason through it. Where should it be? Well, I got 3 up top, 1 down below. 2 should still be on top, right? Does that make sense? That makes reasonable sense. Okay? Now, we're going to square him. So when we square something, when it has all this through, understand this guy has a power as well, doesn't he? Say again, I'm sorry. Oh, sorry, I missed that. I apologize. So now I got 2 options here how to solve this guy. Okay, just from here. First off, I could just distribute the negative 2 through. So that would be 4 to the negative 2. Does everybody understand why that happened? Because I took that power and went in. Because remember, a power to a power, what do? We multiply, right? I take that power into the 5. What's that going to be? X to the negative 10. Y to the negative 4. 5 to the negative 2. Does everybody understand that? Any questions on where I got that from? Nope. When we go power to a power, like we have here, see how everything has a power, and I'm raising it to another power, we multiply.
Back a couple examples.
Remember that? Yes, ma'am.
Okay, so on the second example,
Right here?
yeah, well, on the one above it, you put y over y to the power of 3, and then you put y to the power of 1. So what was on the...
Well, remember I subtracted. What's 3 minus 1?
Oh,
Okay? Now, I got everybody jumping lines, don't I? Right? This guy's going to jump down. What is 4 squared, by the way? 16. This guy's going to jump down, so he's x to the 10th on the bottom. He's y to the 4th on the bottom. And he is 25 on top, right? You see how everything switched because it was a negative exponent? Okay? Does everybody see that? That means if it's a negative exponent, everybody's going to have to jump anyway, right? Does that make sense? So what you could do here, okay, so this goes this direction. Now we could have an opposite direction that gets us the same answer. Watch what I could do here is already flip. And go from a negative to a positive. Because notice that negative automatically makes everybody jump the line anyway, right? Does everybody see that? So do you see how everything that was upstairs jumped down, everything down jumped up? By getting rid of the negative. Now, what's 5 squared? 25. What's 4 squared? 16. What's x to the 5th squared? X to the 10th. Y squared squared? Y to the 4th. Notice we still get the same answer going. Okay? There's 2 options there. Now, you also said, I would like to pull it all the way straight in right out of the bat, right? Okay, so that would be 4 to the negative 2, x to the negative 4, y to the negative 6. Does everybody see that? Over 5 to the negative 2, x to the 6th, y to the negative 2. Okay? Well, that 4 squared is going to have to go down below to become 16. Everybody see that? So he's negative, so he's going to have to jump down here anyway, right? Be 16. What is x to the negative 4th over x to the 6th? Well, they're the same base, and we're dividing, so we can subtract. What's negative 4 minus 6? X to the negative 10. Because he's a negative exponent, he's going to have to jump down anyway. So he's x to the 10. Negative 6 minus a minus 2 becomes y to the negative 4. Because he's negative 4, he's going to have to jump down anyway as well. Many different ways to go at that one, right? Does everybody understand how to go at least when you have numbers raised to a power? Bring them in, work through it, right? Okay. Anybody have a question so far? We're doing fairly well? Let me just see if I've got everything. I'm pretty sure we're getting close. I think you're actually good to go. Hold on. No, one more. Just one more. It is 8:31. So if I had 4a squared b squared times by negative 3a hold on, ab what would that be? What do I distribute through then? The 4a squared b squared. I don't distribute just like terms. I distribute everything. So I go, okay, I'm going to take this guy and multiply it by him, right? Because this is just like being like basically like this. You take him and go into both. And you take him and go into both. That makes sense, okay? Okay. Okay. So I'm going to distribute through. So 4 times negative 3. Negative 12. A squared times a. A cubed, good Adam. And then b squared doesn't have anybody over here to continue on, so he's just still b squared, right? Are you okay with that? 4 times 4, 16. Does a squared have anybody to times with? So he's still a squared. How about b squared? Does he have somebody to times with? B cubed. Can I add those guys together? How? Are they like terms? No, I got an a cubed b squared. This guy's a squared b cubed. They're not the same, are they? So I can't add them. So this would be my answer. So looking at it, Tia, are you wondering why I can't add them? Are they like terms? Like, could we, once again, it's just like going 2a plus a squared. Can I add those guys together? This is one term less than him, just like this guy has one more term than that guy, like meaning a, right? I can't add them together because they're not the same. Yeah. When we're adding, we have to have combined like terms, right? Does that make sense? But when we're not at, I always kind of think about it like this. It's hard on this one, but how do I want to? I don't know. I always think about adding a fruit. That's what it reminds me of. Like this is saying 2 apples plus oranges squared. Can I add 2 apples plus oranges squared together? Or apples squared? I don't know. 3x plus 2y, a lot of